Hello and welcome back to Math with Mrs. Becker. Today in Precalculus, we are starting Chapter 3. 3.1, we will specifically look at something called functions. To understand the origin of the concept of a function, it may be helpful if we consider some real-life situations where one numerical quantity really depends on another one. So here are some examples of input and output of functions. The amount of income tax you pay depends on your income. So when you want to figure out your income tax amount, it depends on your income. So the input is your income, the output is your tax amount. So this means that there could be a formula somewhere along the way where you fill in how much money you make, and the output, what spits out, is how much money, how much taxes you have to pay. Okay, here's another example. Suppose a rock is dropped straight down from a high place. Physics tells us that the distance traveled by the rock in t seconds is 16 times t seconds squared feet. So if you want to know the distance that the rock traveled, you need to have an input. How long, how many seconds since you dropped the rock? So the input is the time in seconds. The output is the distance. If you know how many seconds ago you dropped the rock, you could fill it into the formula, and what the output is, what you'll find out, is how far that rock has traveled. What is that distance? A function, it consists of the following. It has a set of inputs. Your inputs are called the domain. They are your x value. There is a set of outputs. Your outputs, that's called the range. And the range, those are your y values. Now, in order for something to be a function, each input determines one and only one output. So what that means is each x can occur only one time. Otherwise, it's not a function. So here is a relation. A relation is just a set of ordered pairs. To see if it's a function, we need to see if it passes this rule. Each x can occur only one time. Well, inputs are our x's. So we have a 1, 1, 2, 3, 3, 4. So no, this is not a function. The reason why, there are 2 1s and there are 2 3s in the x spot. If it is a function, every x has to be unique. 1 repeats and 3 repeats, so no, that is not a function. If I want to see if this is a function, the x's are 1, 3, 5, 7, 9, and 11. So yes, that is a function. How do I know? Because each x is unique. Each x is different. Now, in order to see if it's a function, notice I did not look at the y value at all. For something to be a function, each x value has to be unique. Like here, this is a function. If you notice, the y values are all the same. That's totally fine. It's all based off of the x's. You can evaluate a function. Now, this is function notation. So this tells us we have a function and our variable is an x. So in this notation, notice what happened is they changed the x to a number. So I go into the function and I replace the x with whatever number is here. Then you calculate using the order of operations. So let's try a few. If I replace x with a 3, I keep this function the same, except for where the x is, I go ahead and replace it with a 3. So underneath the square root, we want to make this one number. Order of operations, use square before you add. 3 squared is 9. 9 plus 1 is 10. I cannot break apart a 10 because that's 2 times 5. There are no pairs of numbers to cross off, so your solution is the square root of 10. If we replace x with a -5, let's see what we get. X is a -5, we square it plus 1. -5 squared. -5 times -5 is a positive 25. 25 plus 1 is 26. 26 is not perfect, so I see if I can break it down. 26 is 2 times 13. So again, I end up with a square root answer that I could not simplify. and that's totally fine. So f of negative 5 equals the square root of 26. What if we turn x into a 0? So the square root of 0 squared plus 1. 0 squared is 0. 0 plus 1 is 1. So underneath, I have the square root of 1. The square root of 1 has a value of 1. So that's how you can evaluate functions. Here's another one. Let's keep evaluating. So g of x, my function is g. That's just the name of it. My variable is an x. Here, if they say g of negative 3, it means to replace the variable with a negative 3. So it's negative 3 squared plus 1. Order of operations, you always do your exponents before you would add. Negative 3 squared. Negative 3 times negative 3 is positive 9. 9 plus 1 is 10. If I have g of 1/2, where the x's, I fill in 1/2. Now, this is a property of exponents that we talked about earlier in the year. If you square a fraction, remember you're actually squaring both the numerator and the denominator. So 1 squared is 1. 2 squared is 4. Now we're going back to like junior high when you really worked with fractions. They want us to add fractions. You cannot add fractions unless you have a common denominator. So 1 is the same thing as like 1 over 1. In order to add it to 1/4, I need to create a common denominator. So I multiply both top and bottom by 4. My 1/4 is good. 1 times 4 is 4. 1 times 4 is 4. When you add fractions, your common denominator stays. So it just carries over. What you're actually adding is the numerator. 1 plus 4 is 5. Last one like this. G of t. So notice all they're having you do here is change the x to a t. So x becomes t squared plus 1. I cannot combine those because they're not like terms. Okay. Now, one big purpose of pre-calculus is to teach you some skills that will carry over into a calculus course when you decide to take that either next year at WDC or when you go off to college, okay? You can find what's called a different quotient. This is a calculus idea. It goes along with this chapter because we are dealing with functions. So there are times where what they want us to do is rather than just fill in a number, they want us to change all of the x's to x plus h. So I go into the function. X becomes x plus h, quantity squared, minus x becomes x plus h plus 2. So it's the same idea as what we just were doing. Where the x was, I replaced it with the binomial. It's a binomial because it has two separate parts, x and h. When you square a binomial, that means that you have this 2 times. So I have to FOIL this. X times x is x squared. X times h is xh. H times x is xh. H times h is h squared. I can combine the middle 2 terms. 1xh plus 1xh, this would become 2xh. So I have x squared plus 2xh plus h squared. So far, what I have done is this. Okay, I just had a power of 2, so I wrote it out twice. I FOILed first, outside, inside, last. I combined the middle 2 terms. Now I keep going. I still have this. Remember, if you have a negative outside of parentheses, that negative needs to go to both terms. So this becomes negative x minus h. Don't forget we have a plus 2 at the end. Now I see if I can combine anything. And if I look, you guys, I can't. So this would be your solution for part A. If I take the function and I replace the x's with x plus h, I would have x squared plus 2xh's plus h squared minus x minus h plus 2. Now notice I didn't change the order at all. Standard form occurs when you only have one variable. That's when you want to put it in standard form, going from the highest exponent to the lowest. Well, this would not technically have a standard form because I have 2 variables. I have x's and h's. Now the next part, I want you to notice that there's overlap, okay? Step 1, they want you to find f of x plus h. We already did that, okay? So for B, we're starting with this. x squared plus 2xh plus h squared minus x minus h plus 2. Then they want us to minus f of x. F of x is the original problem. F of x equals x squared minus x plus 2. So they want us to take what we got from part A and minus the original function, x squared minus x plus 2. Now the reason why this had to go in parentheses is because I'm subtracting something that has more than one term, meaning this negative needs to go to every single term because I'm minusing the whole function. I'm not just minusing the first term. So what I need to do is go ahead and distribute. So I have x squared plus 2xh plus h squared minus x minus h plus 2. I got that from part A. Now I distribute. Minus x squared, negative times a negative is a positive x, negative times a positive is a negative 2. Now I can go ahead and combine like terms. Check this out. Positive 2, negative 2. They actually cancel. Positive x, negative x. That cancels. Negative x squared, positive x squared cancels. So what I have remaining after part B, I just have and here's another piece. Don't let me miss that piece. I hope at home you were yelling at me. Okay, so what I have left is 2xh plus h squared minus h. That is the end of part B. Now part C, what I want you to realize is we've already done the numerator. Our solution to part B, we took f of x plus h, calculated that in part A, took that minus the original function, and I got this. That's what's on the top. So it's f of x plus h minus f of x. What we got is 2xh plus h squared minus h. Now they want us to go ahead and take that and divide by h. If your bottom, your denominator is a monomial, meaning it's only one term, you can separate this into multiple fractions. So what I get to do is take 2xh over h, plus sign h squared over h, minus sign h over h. Now when we simplify it, we have our final solution. H cancels h, so I'd have 2x, plus, if I have two h's and I remove one, remember properties of exponents. You have an h, subtract the exponents. 2 minus 1 is just 1. Minus h divided by h. This is the same thing as like 5 divided by 5. How many times does h go into h? 1 time. Now this is actually a formula that we use in calculus a lot. We use this to calculate what are called limits or to find derivatives using a secant line approach. So if you do decide to go into calculus, you will see this formula quite a few times. But check this out. We broke it down step by step, and we were able to actually find what's called the derivative of this function. So here's what your assignment is. I want you to go ahead. There are 28 questions total. Go to page 148 in the textbook, and you are going to do numbers 13 to 40. Obviously, they're not all going to be super crazy like this. If we look back at the notes, we started with, is this a function, yes or no? Okay, are the x's all unique or do they repeat? Can you evaluate functions, replacing a variable with a numerical value? At the end, we just kind of transition those ideas into an approach where, hey, if you move on to calculus, you will see this again. So again, your assignment is 28 questions, page 148, 13 to 40, and then there is a quick quiz to complete. Quick quizzes just go over the basics. I want to make sure that you understand the key concepts for the day. I hope you guys had a great time, and I'll talk to you soon.